Hello students, in this video we are going to learn how to solve a system of linear equations using matrix method. Let us consider a problem. Solve for x, y and z using matrix method. Here the equation is x plus 2y plus z is equal to 7. The second equation is x plus 3z is equal to 11. And the last equation is 2x minus 3y is equal to 1. Now this system of linear equations in three variables x, y, z can be written in matrix form as follows. Here it is a matrix. This is x plus 2y plus z. This is our first row. X plus 2y plus z. Again here x plus 3z. That means x plus 0y plus 3z. This is our second row. Similarly here 2x minus 3y is equal to 1. That means 2x minus 3y plus 0z. This is a matrix of order 3 by 1. And here the constant terms. The matrix of constant terms 7, 11, 1. This is also 3 by 1. So this matrix is equal to this matrix. Therefore corresponding elements are equal. That means this element is equal to 7. This element is equal to 11. This element is equal to 1. Hence the system. Hence we have written the system in matrix form. Now this matrix can be written as this matrix, the matrix of coefficients. That means here 1, 1, 2, 1, 1, 2. Here the coefficients are coefficients of y. They are 2, 0, 3, minus 3, 2, 0, minus 3. Similarly here the coefficients of z are 1, 3, 0, 1, 3, 0. And this is the matrix of variables x, y, z. This is equal to this matrix. You can see here this matrix is a 3 by 1 matrix, and this matrix is a 3 by 3 matrix, and this matrix is 3 by 1 matrix. Therefore the product is this matrix 3 by 1 matrix. Multiply this row multiplied by this column and you will have this. Similarly this row multiplied by this, you will have this. Similarly this row multiplied by this, you will have this. Therefore this system in matrix form can be written in another way, in this form. Now here this matrix is a square matrix of order 3 by 3. This matrix is A, and this matrix of variables, this is x, this is equal to B. Hence A multiplied by x is equal to B. Now multiplying both sides with A inverse, we have x is equal to, because A inverse A is equal to I multiplied by x, that is x. This is equal to A inverse B. This will be our solution. Now if this is our solution, that means we have to find the inverse matrix of A. This matrix, this is A, the inverse matrix of A, and put here A inverse B, that will give this matrix X, the matrix of variables. Now how to find the inverse of the matrix? This is the problem before us. Now as we know that A inverse is nothing but adjoint A divided by determinant A. Adjoint A divided by determinant A. here. Now it is clear that A inverse exists provided determinant A is non-zero. When the determinant of a matrix is not zero, this is called non-singular matrix. And when the determinant of a matrix is zero, it is called singular matrix. So if the matrix is non-singular, then its inverse exists. Now you can find the determinant of this matrix. Now here 1 multiplied by G, the cofactor of 1 is 0, 3, minus 3, 0, 0 multiplied by 0, 0, minus 3 multiplied by 3, that is minus 9, minus 9, that is plus 9. Similarly, you can, that means expanding this determinant, though it is not determinant, it is a matrix, but you can consider it to be a determinant. So expanding this determinant along the first row, we have the value is 18, and 18 is not 0. That means the matrix A is non-singular, and hence A inverse exists. Now the cofactor matrix of A. You have to find the cofactor matrix of A to get the matrix adjoint A. Now the cofactor, that means to find the cofactor matrix of this matrix A, we have to replace each and every element of this matrix by their corresponding cofactors. And cofactors are minors with appropriate sign. So what is the minor of this? This is the minor of this is, of course, written here. The minor of this is 9. This is 9. Here this is minus multiplied minus, that is 6. Here it is minus 3. So we have written. Why? Because the elements of a row multiplied by their cofactors added together gives us the value of the determinant. So we have written here 9, 6, minus 3. 9 is the cofactor of this position, 6 is the cofactor of this position, minus 3 is the cofactor of this position. Now for this position, this row is deleted and this column is deleted. We are left with 2, 1, minus 3, 0. Multiply it, 2 multiplied by 0, that is 0, minus of minus 3 multiplied by 1, that is minus 3, minus of minus 3, that is plus 3. But its sign is minus, therefore it is minus 3. Similarly here, 1 multiplied by 0, that is 0, and 2 multiplied by 1, that is 2, minus 2. Here the minor is minus 2 and its sign is positive, therefore it is minus 2. Similarly, the cofactor of this position is 7, the cofactor of this position is 6, the cofactor of this position is minus 2, and similarly the cofactor of this is minus 2. So we have the cofactor matrix at hand. Now to find the adjoint, we do nothing. We transpose the matrix of the cofactor matrix of A. So adjoint of A is equal to cofactor matrix of A transposed. And what do we do in transposing? We make each row by columns. That means first row is made into first column, second row is made into second column, third row is made into third column. So here our first row is 9, 6, minus 3, and we are making it first column 9, 6, minus 3. Minus 3, minus 2, 7, minus 3, minus 2, 7, 6, minus 2, minus 2, 6, minus 2, minus 2. This is our adjoint. Now as we know that A inverse is equal to adjoint A divided by determinant A. Therefore, what is the value of determinant A? This is 18. 1 by 18 times this matrix I have written here. Now from 1, this is our solution. X is equal to A inverse B. Now putting the value of A inverse and B, here it is B. We have X is equal to A inverse B, that is 1 by 18, and this matrix. This is the inverse of the matrix and this the B matrix. Now multiplying this, we have this is 9 times 7, that is 63, minus 3 times 11, that is minus 33, 6 times 1, that is 6. Similarly here 6 times 7, that is 42, minus 2 times 11, that is minus 22, minus 2 times 1, that is minus 2. Similarly here minus 3 times 7, that is minus 21, 7 times 11, that is 77, minus 2 times 1, that is minus 2. Now simplifying this, we will have 1 by 18 times 36, 18, 54. And hence the variable matrix, that is the matrix X, Y, Z, is nothing but 18 2 ja 36, 18 1 ja 18, and 18 3 ja 54. Hence X is equal to 2, Y is equal to 1, and Z is equal to 3 is the solution of the system of linear equations. Okay, thank you. दूसरे वीडियो के लिए